Ready, Freddy's? Come on, let's stuck on something. There we go. All right, so perpendicular and angle bisectors. How to use perpendicular and angle bisectors to solve triangles. This? You not seen it? The T upside down represents perpendicular. How many of you remember constructing perpendicular and angle bisectors in IM1? Good. We'll start with perpendicular bisector. Now these are within a triangle, right? But what does it mean to be a perpendicular bisector? First of all, what does perpendicular mean? It does cross at what? Bisector means half. What does perpendicular mean?
Cross at the half.
No, that's bisector.
What does it mean to be up and down? What does it mean to intersect?
Cross and combine.
How many of you remember doing this? Perpendicular bisector means it intersects at what? 90 degrees. Perpendicular means it hits at 90 degrees. Bisect means to cut in half.
Is that your IM1 notebook?
It is a segment, or a ray, or a line that is perpendicular. Know that the perpendicular sign is the upside down T to a segment at its midpoint. Why the midpoint? No, why the midpoint? Because it cuts it in half. Perpendicular means 90 degrees. What is a segment? It's not a line. There's segment, ray, and line. They're three different things.
Starts and stops.
Starts and stops, 2 endpoints. What's a ray?
Starts and goes.
Starts and keeps going. And what's a line? Goes on forever. So I want everyone to hold up your hands. Like this. Segment, ray, line. Segment, ray, so in other words, stop and keep going. Line means what? Keep going in both directions. Do you understand? Segment, ray, line. Okay? Do we got it? All right. So we have it could be a segment, a ray, or a line that intersects. Remember, we're intersecting triangles, correct? So, we need a triangle. That's a P. Degrees means it's perpendicular. Bisector means what does it do to segment AB? Cuts it in half. So what do you know about AB and PB?
They're the same.
What's the word for congruent? That is just the definition. Do you understand? Okay. So it says this. If line CP, hence the two arrows, which means it's a line, is the perpendicular bisector, right? And we can say that AC is equal to CB. I already know that AP and PB are congruent because that's the definition of a perpendicular bisector, right? But now, because I've cut this triangle, I now know that this piece is equal to this piece. And in IM1, you learned something that said you have a side. This side is exactly the same, so it's congruent no matter what. And now we just proved these two sides are congruent. Guess what? The last side is congruent. It's a lovely thing called side, side, side. Remember that? Okay. The other thing we learned in IM1 is that this is side. There's your angle. And there's your side, so side, angle, side. Well, if these three are congruent, guess what you know about these pieces? They're also congruent. It's all IM1. Some of you look at me like I'm crazy.
Would they ever done like the A to like maybe find the side, like the slant triangle? Would they use that problem in the equation?
Pythagorean theorem?
Yeah.
Not in these problems.
Okay.
Eventually, possibly, but not today. Okay? So does that make sense? So we now know this is congruent. We know this is congruent already because it's a right angle. We know this is the same because I've just showed the same piece. I've cut this one triangle into two triangles, and now this is congruent. Make sense? Okay. Some of you just nod and pretend. Angle bisector. What does it mean to be an angle bisector? What does it mean to be an angle? It's an angle. What does it mean to bisect? Cut into what? Two what? Two halves. So two equal parts. It is a ray that divides an angle into two congruent angles. And divides the opposite sides. Remember what it means to be opposite. What does it mean to be opposite? If I said I need to go to the opposite side of the classroom, where would I go? What is that? Across. Across. So if I said, Luis, go to the opposite side of the class, where are you going? Over there. If I said, Brian, go to the opposite side of the class, where are you going? Over there. Got it? It's a cross of a triangle into segments that are proportional to the other side. Did I say congruent? No. I said what? Proportional, which means you're going to be solving what? You're going to solve what? Proportions. Draw our picture. A, B, and C. Nothing's congruent besides the angles. Why are the angles congruent? Because you've just cut them in what? You just cut them in half. Now, proportion. Ready? Here's our proportion. It says that BD over DC equals BA over CA. Why? Because they're not equal. It's proportional. Pay attention. Small over the small equals the big over the big. The other thing you need to notice is this. Top over the bottom. It's the top triangle over the bottom triangle. They have to be in the right order. If you go this over this and this over this, you're wrong. Do you understand? It has to be in the right order. So I went top over bottom, top over bottom. Small over small, small over small. I mean big over big.
Will it be like,
Yeah. It'll be switched, it'll be turned, but make sure you're going left over right, left over right. As long as you're going in the same order.
So small over small, big over big?
Okay? Has to be the right order. Can't be mixed. That's when you get it wrong. We good? 3 examples, here we go. There you go. First example. I'm not telling you which one it is, you just need to know. Check with someone when you're done.
Oh, that's
Weird, I saw him pull up yesterday in like a little Ford. I was
Yeah, I saw
We just started looking, and he realized he was like, Did he get back from No, that's cool. No, I get so stupid.
Bless you. Alright, ready? What do we know? Shh, Emily. What do we know? What do you know first? That BD is what? Is a perpendicular bisector. Since it's a perpendicular bisector, what do you know about A, B, and BC? They're equal. So if they're equal, what can you plug in? Good. And what do you do to both sides? Shh, my turn. What do you do to both sides?
I did minus x.
You took away x?
Yeah. Well, I did plus I added 6 first.
Okay, you added 6, so you get x plus 24 equals 3x.
And then you subtract the x.
Okay, so you get 24 equals,
Oh, so then I got 12.
equals what?
Oh,
2x.
2x.
2x and x equals what? Okay, wonderful. Doesn't matter.
That's it?
Yep, that's it.
Well, Mr. Sanders, I have a question.
Sure.
Okay,
Feeling
how
nauseous.
this is probably a stupid question, but
Go outside.
I did, the first
Stop it.
thing I did was I did AC equals CB, and I plugged in 90 equals 3x minus.
You can't, you're not solving for angles. 90 is an angle, 3x minus 6 is a side. They're two different things. Okay? Shh. Then go outside.
I don't know, but it's really weird. I'm like,
Go outside.
it doesn't work out well.
Okay? We good?
Yeah.
Example B. What do we know? Oh,
I put B, never mind.
you have a what?
BD is over DA.
That's what I did.
How about we say it, Greg? What do you know?
AD
No, Luis, what do you know? It's an angle bisector. So what do you tell me?
Line C and D is perpendicular.
Line CD or segment?
Say,
Segment CD, what? It's an angle bisector. We can't say it's perpendicular because I don't have what? I don't have 90 degrees. Bless you.
you don't have, okay.
So if I know it's an angle bisector, what can you say?
That BC over AC is going to be BD over AD.
I'm going to do AD over BD equals AC over BC. Same thing. Okay, so what do I know?
Equals
15 over what?
21 over 14.
Cross multiply. 21 times x equals 15 times 14. So 21x equals 2 times, so x equals, wonderful.
I feel like I'm overanalyzing this in my head.
Yep.
Do it, you just like make it seem it's very like.
Easy? Because it is. This is the harder one. All right, what do we know? It's an angle bisector. Could you give it letters?
Yes.
All right, so we're going to call this
A,
and this.
B.
This B,
Oh no.
this, and this. Okay. So you know that CD is a what? Is an angle bisector. What else do you know? If it's an angle bisector, then you have what? Proportional sides. What are your proportional sides?
Or AC over BC.
BC over C.
BC over AC equals
AD.
she went here to here, so you have to go BD over AD. Don't confuse yourselves. Or follow what exactly we've done the last two, or this one in the notes, and go in the same order. Okay. So what's BC? 9. What's AC? 12. What's BD? 3. What's AD? We don't know. How do we find AD? You can't call it X. Because I know the whole thing AB is 2x minus 7. And I know that DB is 3. So what is this piece here?
3 put in 2x minus 7 equals 3.
Nope, not equal to 3.
We plug in 3.
I know this is 12. I know this is 3. What is this piece? I know this is 12.
9.
I know this is 3. So how did you do that? No, I didn't. You subtracted. So what did I subtract? What's the whole thing?
3 minus 12.
12
12 minus 3.
12 minus 3. So if I'm going to go 12 minus 3, what am I going to do here? What is it?
2x minus 7.
There you go. 2x minus 7 minus 3. So what's 2x minus 7 minus 3? 2x minus 10. Now can you solve a proportion? Okay, so solve it.
Oh, so that's from last explanation?
No. That's like from piece plus piece equals whole. Oh, this part?
Yeah.
Yeah, that's what I told you guys. That's why I made you do it in class today when I made you come in. There was reasoning behind my logic. I didn't just make it up. All right. How do you cross multiply? 9 times what? 9 times 2x minus 10 equals 12 times 3. So what's 9 times 2x minus 10? Minus what? 90 equals 36. So 18x equals what? 126, and x equals 7 is correct. Get out a sheet of paper. Not from your notes. Yours is different, not you. Your notebook is going to run out. Put your name at the top. Oopsies, wrong way.